Good afternoon to everyone, and welcome to the annual awards ceremony for the National Academy of Sciences. Today we'll be recognizing 19 individuals for their contributions to science. This event is not only happening here in person, yay, but also online, so that all of your distant family, friends, and admirers can hear about your great accomplishments and can share with you in this special day. We're excited to be able to host this ceremony this year one more time in person at our home here in Washington, D.C., after a 2-year absence because of the pandemic. Now, of course, we did give awards during that period, but it wasn't quite the same. So we did invite the award recipients from 2020 and 2021 to come to this event so we could recognize them. Not all were able to make it, but if you're a 2021 or 2020 award winner, I'll ask you now to please stand up so we can give you a rousing round of applause. So thank you, and I'm sorry we couldn't have done this the ceremony in person for all of you when you did win your awards, but that doesn't make them any less important, and your names will be forever engraved in our members' room. So the first awards we're going to give this year are for the Cozzarelli Prizes. The Cozzarelli Prizes are named in honor of the late editor-in-chief of PNAS, the Proceedings of the National Academy of Sciences, Nicholas Cozzarelli. And because there are 6 classes in the National Academies, our National Academy of Sciences, there is one prize for each of those classes. Now, if I shuffled all of these cards for the various classes and asked you to guess which class it came from, I'm guessing you wouldn't get them all right. So I'm going to tell you which class it is. So first of all, the winner for Class 1, which is Physical and Mathematical Sciences, is a paper named Chromatophores Efficiently Promote Light-Driven ATP Synthesis and DNA Transcription Inside Hybrid Multi-Compartment Artificial Cells. So that was Physical Sciences. A major goal of synthetic biology is constructing artificial photocells, which are proposed to be precursors to cellular life. One challenge facing artificial protocells is autonomous energy generation. The authors of this study entrapped structures called chromatophores from purple non-sulfur bacteria in giant lipid vesicles, along with the components for synthesis of ATP, the cellular energy currency, and gene expression. The study shows how bacterial chromatophores can fuel artificial cells. So congratulations to the authors of that paper. And when we congratulate for each of these papers, if any of the authors are here, feel free to stand up and be recognized. The next one is for Class 2, Biological Sciences, for a paper named Recombination Independent Recognition of DNA Homology for Meiotic Silencing in Neurospora crassa. During the process by which sex cells are produced, homologous chromosomes pair with each other in a process called recombination. The authors of this study uncovered a recombination-independent mechanism for chromosome homology recognition by studying a process called meiotic silencing by unpaired DNA in a fungus. The authors' biophysical model helped uncover a novel mechanism for homology recognition during meiosis, an essential process for ensuring fertility and preventing birth defects. So congratulations to the authors of that paper. The next one is Class 3, Engineering and Applied Science, for the paper Optical Computation of a Spin Glass Dynamics with Tunable Complexity. Spin glasses are disoriented systems that serve as models for phenomena such as brain function, random lasers, and quantum dynamics. However, calculating the energy of the equilibrium states of spin glasses is challenging. The authors of this study developed an optical method to calculate the energy of a spin glass state. The findings carry potential implications for improving neural networks for sound recognition, image reconstruction, and high-definition fiber and endoscopy. So, congratulations. I thought Dr. Parisi was here, or maybe he was. Anyway. Okay. Next, Class 4, Biomedical Sciences. This award is being given for the paper Lipopeptide-Mediated Bacterial Interaction Enables Cooperative Predator Defense. Communities of microbes can cooperate to defend against predators. In this study, the authors found that two unrelated bacterial strains, each susceptible to predation by amoebae, exchanged natural products to defeat predators when they were grown together. This study shows how microbes work together to guard against predators and suggests that microbial interactions may be a source of novel bioactive compounds. So congratulations to those authors. Class 5, Behavioral and Social Sciences. The award is being given for the paper Learning Loss Due to School Closures During the COVID-19 Pandemic. So, school closures during COVID-19 are thought to have harmed children's education. The authors of this study analyzed students' exam scores covering 15% of all primary schools in the Netherlands. An 8-week lockdown, when face-to-face instruction was suspended, was tied to a learning loss equivalent to 1/5 of a school year. This loss was exacerbated among students from disadvantaged homes, showing the uneven toll of school closures on student learning. So congratulations to those authors. And finally, Class 6, Applied Biological, Agricultural, and Environmental Sciences. The award is being given for the paper Enlisting Wild Grass Genes to Combat Nitrification in Wheat Farming, a Nature-Based Solution. Nitrification, a process triggered by nitrogen fertilizer use, can harm soil fertility and ecosystems. The authors of this study uncovered a genomic segment in wild grass that controls the production of nitrification inhibitors from plant roots. Transferring this genomic segment into high-yielding varieties of wheat nearly doubled the ability to block nitrification and increased grain yield in some varieties. The findings could help combat nitrogen pollution without affecting yield or agronomic qualities. So congratulations to these authors. Okay, now to the awards for scientists. The first is the Alexander Hollander Award in Biophysics. This year, it's being awarded to Wolfgang Baumeister of Max Planck Institute for Biochemistry. It's given for his pioneering contributions in the field of cryogenic electron tomography and obtaining biological insights into large macromolecular assemblies, especially the proteasome and proteins involved in neurodegeneration. So, Wolfgang.
Thank you very much, Dr. Metnack. I feel very pleased and honored to receive the Alexander Hollander Award, which has been given in the past to many distinguished biophysicists. I'm humbled to join the company of these individuals as the recipient of this year's award. It recognizes our efforts over a period of more than 3 decades to develop cryo-electron tomography as a tool, making possible the exploration of the inner space of cells in molecular detail. I did not do all this by myself. I owe an awful lot of thanks to generations of highly motivated and capable graduate students and postdocs. It's gratifying to see how our joint efforts have developed into a vibrant field in situ structural biology. For obvious reasons, I wish to thank the National Academy and the Biophysics Committee for conferring this award to me. Thank you.
Next, we have 2 Atkinson Prizes in psychological and cognitive sciences to be awarded. The first Atkinson Prize is awarded to Mahzareen Rustam Banaji of Harvard University for her pioneering work in establishing and quantifying the role that unconscious processes play in governing human social actions and judgments of others.
Science is never I. Science is always we. Here are the we's that I am compelled to recognize. Rustam and Kumi Banaji, my parents, elicited from me a love of learning, even when it meant that I always opened even the newest, shiniest toy to see what was inside of it. Tony Greenwald, my advisor, taught me a ruthless self-criticism and the thrill of reaching beyond my grasp. To my remarkable graduate students and postdocs who surpass me in every way, please know that this Atkinson Prize is for your cumulative work. R. Bhaskar has been my partner of 42 years, or so I thought, but he reminded me that it is still just 41 years. It just feels like 42 to me. I thank him for his unshakable faith in me when I had none, and for his practice of feminism, which also preceded my own. And finally, some breaking news. The state of Florida has just banned the use of math textbooks that use our data to teach children polynomials. Because our work is in the thick of being censored in several states, and even legal action threatened against those who teach it, I thank the Atkinson Prize Committee, whoever you may be, for the timing of this award. Thank you.
Thank you. So the second Atkinson Prize is awarded to Dan Jarafsky of Stanford University for his groundbreaking contributions to computational linguistics and the sociology of language, with significant applications to machine learning, artificial intelligence, and social justice. So, Dan.
Thanks, Dr. McNutt. It's awesome and humbling to be in the company of my amazing co-awardee, who's a very hard act to follow, the pioneering prior awardees, and my wider multidisciplinary community of colleagues and students who apply computational thinking to better understand human language and society while simultaneously working to bring social, humanistic, and ethical concerns into machine language processing. Thanks to my wife Janet, to my mentors, and to the amazing students and postdocs across so many disciplines I've been so lucky to collaborate with. The late great food writer Jonathan Gold said that beautiful things are often found in the fault lines between cultures. That's true at the intellectual boundaries in science too, and it's so wonderful that the National Academy recognizes this beauty in liminal spaces. Thank you.
So I understand what you're saying, Dan. You wish your work were banned in Florida. Next, we have the James Craig Watson Medal. It's awarded to Samuel Harvey Mosley, Jr. of Quantum Circuits Incorporated and Goddard Space Flight Center for applying creativity, a deep knowledge of physics, leadership, and perseverance to conceive and develop technologies and instruments used by astronomers worldwide to revolutionize cosmology and astronomy at X-ray and infrared wavelengths while mentoring the next generation of astronomical pioneers. Sam.
Good afternoon. I'm honored to accept the James Craig Watson Medal. Thank you to the Academy for this recognition. But I have to thank my mentors, Al Harper, who introduced me to infrared astronomy, Mike Hauser, who brought me to join the Cosmic Background Explorer team, which was a great experience. Studying physics with John Mather as we built COBE was one of the most important opportunities of my life, so it was critical. My colleagues Dan McCammon, Rich Kelly, and Andy Szymkowiak were essential to the development of the X-ray microcalorimeters, which are now the sort of next generation approach to X-ray astronomy. Rainer Fettig, Alexander Kudarev, Bruce Woodgate, and Mersey Jabala were integral to the development of the microshutters, a key tool for cosmology with the James Webb Space Telescope. I'm deeply grateful to my wife, Sarah. In our 50 years of marriage, we've built a life around our mutual love of science and building things. Curiosity continues. Our son Samuel is an engineer, his wife Kristen is a scientist, and our granddaughter Vivian is asking new and interesting questions. Thank you all.
So before I introduce this year's James Prize recipient, I'd like to take a moment to remember Bob James, who sadly passed away last September. Bob was the former chairman and CEO of McCann Erickson Worldwide and was introduced to the National Academies in 1993 when he began his 16 years as a member of the President's Circle. Bob's generous gift that endowed the James Prize ensures the recognition of outstanding contributions of researchers who work across major disciplines. He hoped that his gift would inspire others to support the NAS mission by providing leadership in science for the nation and the world. One of Bob's grandchildren is with us today, Brian James, and he's pursuing a career in science at Woods Hole Oceanographic. Would you like to stand, Brian? Thank you. I'd like to read you a short excerpt from a very nice note I got from Bob's widow, Anne, after his passing. And what she said, Bob was so proud of the James Prize that he got his special idea to become a reality. Allison, who's head of development here, informed me of the latest recipient, John Rogers, a triple member of all three academies who exactly fits Bob's ideal for this award. He sounds like an amazing man, and our thanks to the NAS Council for this perfect selection. And let me now tell you more about John Rogers from Northwestern University, who is the recipient this year of the James Prize. The prize is given in science and technology integration. And John Rogers is being recognized for his development of unique biocompatible forms of electronic, optoelectronic, and microfluidic technologies, pioneering their use in areas ranging from neuroscience to clinical care, and converting them into widely available forms through interdisciplinary approaches in material science, technology integration, and translational research in health and medicine. So, John, please.
Well, thank you, Dr. McNutt, for that very kind introduction. It's a tremendous honor to receive this award. It's one designed to recognize work that features science and technology integration a really interdisciplinary style that nicely characterizes my own approach to research, where our focus is on developing engineered microsystems inspired by or capable of intimate integration with living organisms, combining essential aspects of engineering, science, and medicine. And so as such, I'm just a representative of a broader team of collaborators spanning fields as diverse as computational mechanics, chemistry, cardiology, and condensed matter physics. And so I'd like to take this moment to call out a few of those collaborators who were particularly valuable in this work. Yonggang Huang, a theoretical mechanician, Ralph Nuzzo, a physical organic chemist, Rob Giroux, a neuroscientist, Steve Zhu and Amy Poller, both academic dermatologists, Debbie Weissmeyer, a neonatologist, Igor Efimov and Rishi Arora, cardiologists, Zach Ray and Matthew Potts, neurological surgeons, and many others. And I also want to thank a vast collection of graduate students and postdoctoral fellows for their many key contributions over the years. But finally, I'm deeply grateful to Bob and Ann James for their vision and initiative in establishing this new and unique award at the Academy. Thank you very much.
Next up is the Jesse Stevenson Kovalenko Medal. It's awarded to Katalin Kariko and Drew Weissman of the University of Pennsylvania for their pioneering work in developing nucleoside-modified mRNA, the foundation for the first two approved COVID-19 vaccines.
I am very grateful to the National Academy of Sciences to jointly receive the 2022 Kovalenko Medal with my colleague and longtime collaborator, Drew Weissman. It is a privilege to belong to the group of scientists, those distinguished scientists who get the same award before us. This award recognizes those fellow scientists who work diligently over decades to help build the foundation for our work that led to the development of the COVID-19 mRNA vaccine developed by BioNTech, Pfizer, and Moderna. For me, it was a long, winding road on which I arrived here from a small Hungarian town. I am very grateful to all of those who helped me on my journey, my teachers, my colleagues, my mentors, and above all, my family, my parents, my sister, my daughter, and my husband, who is here with me today and who always supported me to realize my dream. Thank you so much.
Thank you. So I have very little to add after Katie, but don't clap yet. I need to thank my wife, Mary Ellen, and my daughters, Rachel and Allison, for putting up with me for all of those years of the struggle to make RNA happen. Most importantly, Katie and I are receiving this award, but who really needs to be awarded are the thousands and thousands of scientists before us and the scientists after us who are going to take this technology and bring it to great new potential. Thank you very much.
Well, that was wonderful. The John J. Carty Award for the Advancement of Science is being presented this year in the category of infectious disease. What a surprise. It's being awarded to Barney S. Graham, formerly with the National Institute of Health, for his seminal contributions in elucidating optimal viral glycoprotein structures that elicit superior vaccine-induced protective immunity. Hundreds of millions of vaccine recipients are protected from life-threatening COVID-19 thanks to his work across the globe. His innovations in vaccine design are portable, providing effective countermeasures against other high-threat human viruses. Barney.
Thank you for this great honor. It's especially gratifying to be nominated by colleagues who were involved in the very work for which I am being recognized. The emergence of new technologies and knowledge has transformed the field of vaccinology and launched a new era characterized by precision antigen design and platform manufacturing of biological countermeasures. The rapid development of COVID-19 vaccines and therapeutic monoclonal antibodies is a testament to the critical value of basic research that provides essential foundational knowledge for product development. More than 40 years of basic research and scientific discoveries by hundreds of investigators brought us to the point where atomic level structure and protein engineering provided the antigen design tools, and advances in nucleoside and lipid biochemistry provided the delivery approach needed for highly effective mRNA vaccines. Many thanks to the Academy, the selection committee, my nominators, all the students and colleagues who contributed to the work, and my wife, without whom this would not have been possible. Thank you very much.
Next, we have the Miriam Mercicani Prize in Mathematics. This year, it's being awarded to Camilo Delelis of the Institute for Advanced Study for his fundamental contributions to the study of dissipative solutions to the incompressible Euler equations and to the regularity theory of minimal surfaces. Camilo.
I am deeply honored by this recognition from such a prominent learned society as the National Academy of Sciences. I wish to thank my colleagues for their appreciation of my work and my many mentors, collaborators, postdocs, and PhD students who helped me in this journey. Above all, my friends and collaborators, Laszlo Zekai-Hidi and Emanuele Spadaro. I always dreamed of being a scientist since I was a small kid. And today I wish to remember one person who was there at the very beginning of this dream, my maternal grandmother, who just passed away a few days ago. I need to apologize to her. So many of you, I'm sure, are aware of this. Sometimes immigration is actually so complicated that hopping on an airplane and going to the funeral of your grandmother on Monday is actually quite complicated. Scusa nonna, mi dispiace.
Well, thank you for being here, and our condolences on this terrible loss. The Michael and Sheila Held Prize is awarded to Amit Suhai of the University of California, Los Angeles, for a leading role in development of cryptographic software obfuscation and its application, starting from initial conception of indistinguishability obfuscation and culminating in new constructions based upon well-founded cryptographic assumptions. These breakthroughs highlight how computational complexity can enable secrecy while computing in insecure environments.
I'm grateful to the National Academy of Sciences, my nominators, and the selection committee for this great honor. This work is the result of trying to follow Steven Weinberg's phenomenal advice to go for the messes in science. And as a result, it's also the accumulation of many years of humbling failures to try to accomplish what we did, along with a few good successes. I accept this honor on behalf of my many colleagues and collaborators and students, especially Ayush Jain and Rachel Lynn, Brent Waters, Boaz Barak, and too many others to mention by name here. Stepping back for a moment and just thinking about the totality of my life, I'm extremely grateful for the love and support of my dear friends and family, especially my parents who are here, my brother, my dear wife, Pragati, and my sons, Vigyan and Vatan. And above all, I thank the divine foundation of existence without which nothing would be possible. Thank you.
Now for the NAS Award in Chemical Sciences. It's being awarded to Esther S. Takeuchi of Stony Brook University and Brookhaven National Laboratory for her pioneering study and exploitation of electrochemically induced reduction displacement reactions, use of fundamental electrochemical principles to advance electrochemical energy storage science, and successful introduction of medical device battery that has extended and improved millions of lives.
I want to start by thanking the nominators, the committee, and the Academy for the Chemical Sciences Award. I'm really honored to be considered among those who have received this award previously. It's a remarkable group of individuals. My journey in studying the complexities of the chemistry and materials science of batteries did start with medical batteries, where small size, long life, and predictability was the key. And it had tangible and direct impact on individual people, many of them. Now we've moved on to study batteries for a new energy landscape, electrified vehicles, batteries to back up renewable energy, with potential for even greater impact than those medical batteries in terms of the numbers of people that can be affected. I've not traveled on this journey alone. I want to start by mentioning my parents, who were displaced persons during the Second World War, leaving Riga, Latvia, with nothing more than a suitcase, arriving in the United States, starting life here and convincing me and my siblings that the value of an education is something that can never be taken away, even when circumstances in life, as they had witnessed, remove everything else. I particularly want to acknowledge my husband, Professor Kenneth Takeuchi. He's been an inspiration, a mentor, his unbounded intelligence. He's been at my side for all these years, and truly without him, I could not have accomplished what I have. I've found when studying really complex scientific problems that collaboration is really a key. That's how the best science happens. And I've been privileged to have many, many collaborators, graduate students, postdocs, who have contributed to making this science a reality. One standout is Professor Amy Marshalock, whose endless enthusiasm, energy, and fearlessness has always propelled us in new directions. I accept this honor not just an award for what has been done, but as inspiration to move on to the challenges and to address the issues of importance that still face the nation and the world, and looking forward to many great more things. Thank you.
The NAS Award in Early Earth and Life Sciences, also called the Charles Doolittle Walcott Medal, is awarded to Mary Drosser of the University of California, Riverside for her pioneering discoveries and insights that changed our understanding of early animals, their communities, and their environments, and for her innovative and rigorous field methods, and for her exemplary leadership as a colleague, mentor, and public voice for science. Mary.
Thank you. I'm honored and humbled to get the Charles Doolittle Walcott Medal. I've been incredibly lucky to have had a fabulous group of colleagues, role models, and mentors throughout my career. My oh-so-clever and inspiring students are why I'm here. And I also need to thank my family. My mom spent almost as many months in the field as I have watching my kids as they were in diapers. My siblings, sibling-in-laws, nieces, nephews, everybody has been dragged in the field with me. My husband has been a constant source of support, encouragement, and also having a steady sense of humor. And finally, my kids, Emmy and Ian, who are my greatest experiment, enrich and survived, not only survived, but thrived, spending every one of their summers in the Australian outback. They make my life much more fun. Thank you again, and I am just honored to be part of this group. I mean, seriously. So, really nice to be part of you all here. Thank you.
The NAS Award in Molecular Biology is awarded this year to Carrie Parch of the University of California, Santa Cruz, for pioneering studies revealing protein dynamics and interactions at the core of molecular circadian clocks from cyanobacteria to humans.
Thank you, Dr. McNutt, and thank you to the Academy for this incredible honor and to my colleagues who nominated me. I am deeply grateful for the impact of my mentors, Aziz Sanjar, Kevin Gardner, and Joe Takahashi, who all taught me to follow my unique vision to study and dissect the biological clocks that link our lives intimately to the rhythms of Earth and beyond. I would like to acknowledge the continual support of my family. My mother, brother, and fathers are here with me today. My husband and 2 sons who are back in Santa Cruz. My colleagues at UC Santa Cruz who make work a terrific joy every day. And our many collaborators around the world who have helped us on this discovery. Finally, I'm indebted to the curiosity, insight, and creativity of the graduate students and postdoctoral fellows who have gone on this journey of discovery with me. It's been an incredible honor working with you. Thank you very much.
Now the NAS Award in Neurosciences. It's awarded to Nancy Canwisher of the Massachusetts Institute of Technology for her groundbreaking insights into the functional organization of the human brain, including the discovery of neocortical subregions that differently engage in the perception of faces, places, music, and even what others think, thereby linking modularity of mind theories directly to neuroscience.
It's a huge honor to receive this award. The awards hardly feel necessary when science is already an extraordinary privilege and a grand adventure. But I happily accept it anyway on behalf of the many brilliant young scientists I've had the great fortune to get to work with. Watching these talented young scientists hone their skills and take flight is truly the greatest joy in science. I wouldn't be standing here today if not for the unwavering encouragement and support of my parents, Joan and John Canwisher, and my brilliant scientific mentors, Molly Potter and Ann Treisman. And finally, I want to express my gratitude to my partner, John Rubin, who has kept me optimistic and laughing ever since grad school.
The NAS Prize in Food and Agriculture Sciences is awarded to David Lobel of Stanford University for his pioneering research in innovative use of remote sensing and modeling to address challenges at the agriculture-environment interface that has revealed crop responses to global climate change, informed strategies to minimize the environmental impact of agriculture, and identified novel adaptations and investments for improving world food security. David.
Thank you, Dr. McNutt. I'm really honored to be here, obviously. I want to start by thanking the Foundation for Food and Agriculture Research and the Gates Foundation for establishing this prize to really highlight the importance of food and agriculture and put it on the same setting as some of these really prestigious and established fields. And also to the committee members who took the time to evaluate candidates, thank you. I want to acknowledge all of the great students and collaborators I've had, especially those working on the front lines of helping farmers around the world who have really taught me most of what I know about agriculture and have inspired me along the way. I want to thank the many mentors I've had, especially those who gave me confidence very early on to take the risks that you need to really achieve great things in science, and especially to Chris Field, I think, who's here tonight or today, who nudged me towards thinking really about climate change and what that implies for agriculture, and far before most people were really taking it very seriously. And most importantly, I want to thank my family, especially my wife Stephanie, who I've been with not quite the 50 years that some of these fellow awardees have mentioned, but hopefully we'll get there. She's been with me throughout my whole career. She's kept me happy and humble, and I know she's sacrificed a lot so that I could pursue my own research. So thank you.
The Predell Research Award is awarded to Edward Cheng of the University of California, San Francisco, for his pioneering work on the representation of speech perception and speech production in the human brain, carried out through his advances in the technology of neural recordings and their analysis, and by the design of experiments to reveal the features represented. Eddie?
Thank you so much for this tremendous, tremendous award. I wanted to first thank the nominators, the selection committee, and the National Academy of Sciences for this incredible recognition. I am accepting the Predell Research Award on behalf of my students and fellows who I have really been lucky to recruit from fields as diverse as engineering, medicine, linguistics, and beyond. This adventure that we've taken to understand the neurological basis of words and language and consonants and vowels has been an extraordinary journey for us and our team. And I thank all of the people that have helped us to achieve the goal so far. There is so much yet to still discover. I want to thank my parents who've given me tremendous support over the years, my kids, Parker, Dylan, and Stella, and mostly my wife, partner, Dr. Michelle Arnold, who's sacrificed so much and supported me through this endeavor. Thank you so much.
So now we have 2 Trolland Research Awards to be awarded. The first Trolland Award is awarded to Ruspa Kiani of New York University for his seminal contributions to understanding visually based decisions. By employing an artful combination of theory, experiment, and computational analysis, he has advanced our knowledge of the neural mechanisms underlying decision confidence and hierarchical strategies for decision-making, which has propelled the field to new levels of insight, creativity, and rigor.
Thank you so much. I'm very much humbled and honored by this amazing recognition. This award really belongs to the amazing people who shaped me as a scientist, my mentors, Mike Shatlin, Bill Newsom, Hossein Esteki, and Keiji Tanaka, as well as many colleagues who inspired me along the way, many of them present in this room. I also deeply appreciate my graduate students and postdocs whose brilliance and friendship really enabled every science that I've done so far. I would like to thank my parents, my siblings, and teachers who kindled the love of science in me from an early age. Also, I would like to thank my wife, Sharre, and our son, Suran, who are here. They inspired me very much, and they keep inspiring me and shaping my science as I move forward. Thank you so much.
The second Trolland Research Award is given to Lee Somerville of Harvard University for her pioneering research on how brain development shapes psychological functioning from childhood until adulthood, including how brain and psychological development are intertwined during human adolescence. Her work has begun to provide explanations for patterns of behavior that uniquely categorize adolescence. Lee.
Thank you so much to the National Academy for this great honor. I'm very humbled to receive it. I'd like to start by thanking the key support of a wide range of collaborators who I've learned so much from and who make doing science so much fun. Our work is fundamentally rooted in a team science approach, and we couldn't possibly do it alone. So I'd like to acknowledge them for all their contributions to our work. I'd like to thank the many children, teens, and families across the country who have volunteered as research participants in our studies, letting us collect images of their brains while they have to stay very still, giving us samples of their saliva and blood and hair to measure pubertal hormones, and undergo many surveys and tasks that fundamentally allow us to ask the questions that we do. And some of them even were willing to do so during a global pandemic, so special thanks to them. Relatedly, I'd like to thank my own family and my partner Jerome, who's here today, for their support. And finally, I'd like to acknowledge the brilliant and dedicated trainees, past and present, who I've had the honor of working with over the years. My work is really their work, and so I'd like to dedicate this award to them. Thank you.